All right, let's do active patterns. Since this active patterns is something which really belongs to pattern matching. Now, the kind folks who designed F#, they realized that the pattern matching was very useful in order to write readable, succinct code. So they also came up with a nice idea: make it programmable, so we can actually write our own pattern matching functions to match on things. So, and these are called active patterns, and this is sort of a bit of a corner case in F#. This is not something that you probably will use, at least in the beginning, a lot, but it's good to know about, and when you need them, they can really make code much more readable. So these are not like fundamental in the sense that you don't really need these. You can do well without them, but when you actually need them or want them, they can actually help you make your code much easier to read, right? So, and these active patterns, they come in 3 flavors. And they're slightly confusing. I mean, when I need them, I always read the manual and go like, oh wait, what was this? But once you get the hang of it, it's pretty straightforward. But they come in 3 distinct flavors. And I'm going to start by covering the first one. So the way you define an active pattern is by defining a function which takes the input that you are trying to match on. So in a match expression, you would say match x with, so now you need to take a function which takes that x and tells the matching machinery, gives it back a indication on what it should do. So the simplest thing is really to partition data. That's all you can do with it, really. And that's basically splitting up on cases. So think that you don't have a union type for something, but you have some data that you need to partition into various groups. It could be a numerical, so you could say, well, if the value of this thing is less than then we should do this or that or that. And you could just do that with a normal if-else expression, or you can use an active pattern for it. I'm going to redo this user admin guest example using a match expression. So the way we do this is that we say let, and now we give the name of the matcher, this matching function, and it has a special syntax. So it starts with a parenthesis and a pipe. These are called banana brackets. And now I'll give the cases. Admin, pipe, user, pipe, guest, and banana bracket. And then it takes a input, imp. And this is just a normal function. It just has this funny name. And in this case, this function is very much restricted on what it can return. So when I have these multiple choices that that I'm processing, I'm really restricted in what I can return. So now I can say, well, okay, if system db dot query imp something equals admin. So we'll do some system database query on the input. So we can do some really complicated stuff here. Returns me the string admin. Then admin. Else if something, then user, else guest. Right? So in this case of active patterns, I have 3 cases, and I can check my data, the stuff inside input, and I can then just return return the label of each case that I have defined. And now I can say something like this: match some string that I have, let's call it USR, with admin, then, and I can just check on the label admin and then do something, or user, then do something else, and so on. And we see that we just recreated the example I had from the previous situation where I had all this information in a union type, and I'm able to partition my data based on this. So I just basically did a very trivial union type with for a string input. So that was case one. So the second case is a little bit more exciting actually, because it allows us to deconstruct and reconstruct data. So we can actually do cool things. Like also, I mean, a classical example of the previous one where you want to partition your data is that you could say, well, you could match on even and odd. So then you could say match some number with even, do this, odd, do that, which is much more readable than if some mod to blah blah. It reads easier. Now, but let's look at another example. I'm going to do a banana bracket. I'm going to call it pair up. Pair up. Oops. Imp. So now I defined a matcher which with just one single case, and this is important. This one has only one case in it. This cannot have multiple cases. And I take some input. I'm going to call it x, by the way, so it's easier. And I'm going to make this really simple. It takes an x and it creates a tuple x, comma, x plus 1. Pair, it creates a pair, right? So this is actually deconstructing some data. I can return whatever I want really here. It takes some input, and I can use that input to return whatever data I want. So now I can say match 42 with pair up. And since it returns data now, I can say, well, I could say x, and then I could say print fsd on x and snd on x, or I can do some more pattern matching on it and just say pair up a comma b. And this in this case would actually contain 42 and 43. This tuple. In fact, I don't even have to do a match expression. I could use this in the following way. I could say let some function f, which takes a single argument, which is of the type pair up x, comma y, equals, and then I can just use x and y inside of this function just like normal, and I can call this function with f5, which generates a 5,6. Pretty cool. So one use for this is you can create something like a default value, for example. And then whether you have given something or not, it will either, so then this would return either or depending on, so you could say default some x, and then whether, if you call it with a string which is less than 5 characters, then it's too short, and then it will give you the default value, or whatever you want. I mean, this is just your imagination putting limits on things. And the third and final case that we have is almost the same as this previous one. And I'm going to go back to my user group example and see how we can do it slightly differently. So I could define that as let banana bracket admin pipe underscore. So what this says is that this is an incomplete pattern. It will match on admin or not. And it takes an input, and now I can check whatever I want, and if I find out that, yeah, okay, this is an admin, it will, so if some condition, then it will return some value that I just computed, which could be whatever. It could be tuples or records or what have you, strings. Else none, right? And then I can create exactly the same scheme here, but for also for user and for user and for guest. Similar functions, one per case, and then I can actually do things like match x with admin u something something user u and guest u and so on. And what happens here is that now the matcher will come in. It will try this admin match at first, so it will call this function, and if it returns none, it will continue on to the next case. And if it returns none, it will continue on to the next case. And in this case, I also would have to have a catch-all here. I can't really be sure that it's going to match anything. So it just gives us this possibility and option to match up things. And again, the value I return here is the one that I can bind to a variable in this match expression. And then use, just like in normal match expressions. And then there is this final little addition to this whole thing, which makes it even more powerful, and that's these functions can actually take arguments. So you can parameterize them. So one kind of nice example. Okay, let's do a quick little other example of how we could use this maybe matching patterns before we do the final one. So let angle bracket or banana bracket email. So this is a matcher to test whether something is an email or not. And I'm not going to do this properly because that's beyond this is not really the point of this whole thing. But let's check for whether something is an email. And that for sure can fail. Given a string, I just call it str as the input. This thing can certainly fail. So this is what we want to test. So now I could say, well, okay, if regexp, and then we need to give it a regular expression, would be something dot star, this is really gung-ho email, dot star at dot star forced, so we demand that it has at least one dot in it, dot star, match, then some, and so on. So we extract the email and so on. So else none. Right? So now I could just do something like trying to see if, oh, is this an email? Match email E, otherwise something else. And it, again, a nice way of getting sort of this data extraction, data transformation thing into a form where it's easy to read. Match expressions become very beautiful in code because everything is lined up very nicely. So this is one case. And the final case that I wanted to show was that you could actually have, we could envision that we can put some requirement n on this email string. How many dots must there be after the at, for example, or something? And we can actually give this, we can give an extra argument. But you can only give this extra argument to the two cases where you have, where you are transforming data. The first case I talked about, where you are just partitioning data, it doesn't accept any arguments. So this is sort of a little, just beware. So now I could do something like, suppose I would implement this so that I could say, well, 1 would mean that it would be gmail.com type style, and 2 would be some subdomain of that would be some foo.com, and so on and so on. So I can actually sort of know how many dots there are in the address bar. So we have an implementation for that, and now I can say match string with email, and I can now give it, so say 2x, and I could do a 3x, and then of course the match whatever. Yeah? So this can sometimes be very useful, because then it allows us to write these matcher functions much more general, and you can just give it the argument that you need to affect how exactly it's operating. And yeah, go and play with these. Match active patterns are fun. And that's it. That's pattern matching. Active patterns is a little sort of extra thing. It's nothing that I expect anybody to actually use in the course, but you are certainly allowed to do so, and if you like to. All right, until tomorrow.